So the derivative f divided by g, again, it's g sub x times f prime of x minus f of x times g sub prime of x divided by g squared. It does make a difference which one you write first on the top because that's a minus between them. Remember in the product rule, if you flip-flop them, it won't matter. Here it does matter. So the bottom times the derivative of the top minus the top times the derivative of the bottom divided by, notice the bottom square, not the derivative here, just g sub x. So here we go. If you have y equals, an example, y equals 5x minus 2 divided by x squared plus 1. You can't simplify that. The only way to do that is using this method right now.
Should you always try to simplify it?
If you can cancel that, make it non-fraction, why not? But there's no way I can make this non-fraction. If it was, for example, x squared minus 1 over x minus 1, I could factor it and lose something. Yeah, okay. So the quotient rule here, again, f is the top. And what's the derivative of that? Notice I like to do these first. This way I'm not looking back and forth. I'm trying, so when I get to that equation, just plug in the values. G sub x, x squared plus 1. The derivative of that is what? 2x. Again, what's y sub prime? Or the derivative? It's g times, I'm getting lazy now, f prime minus f times g sub prime. I'm taking the x out. I think you get the idea. Over g squared. What is g equal to? X squared plus 1. What's f prime? Times 5 minus f, which is 5x minus 2 times what? G sub prime, which is 2x. The whole thing divided by x squared plus 1 squared. And again, there's a very good chance they'll ask us to simplify the top. The bottom, you can leave it the way it is. So that'll be 5x squared on the top plus 5. What's 2x times 5x? That's a minus 10x squared. That's a plus 4x, because minus a minus plus. And what do we have? Negative 5x squared plus 4x plus 5 over x squared plus 1 squared. Now, where people get in trouble, they get carried away with it. I'll show you an example. And we can still do it, but why? They'll see a problem like this. Let me make sure I put these in the right order. Yeah. They'll see a problem like this one. Y equals 5x to the 4th divided by 8. They go, oh, the quotient rule. What's the derivative? Well, that's a fraction, right? We're looking for the derivative. So people say, well, since you got a fraction, I should use the quotient rule, right? Why not?
Because the bottom zero.
Yeah.
Well, remember, the quotient rule, you don't take the derivative of this.
Right.
So f of x is what? 5x to the fourth, f of x. The derivative is what? 20x, yep, cube. G sub x is what? 8, and what's the derivative of that?
Zero.
That's okay. You can have a 0 for a derivative, because the equation says, it says g times f prime of x minus f of x times g sub prime of x divided by, not the derivative, divided by g sub x squared. That's the rule. Plug in the values. Do we know what g sub x? 8. I'm sorry. Yep, it is 8. What's f prime of x? 20x to the third minus f of x, which is what? 5x to the fourth times g sub prime, which is what? 0 divided by 8 squared. That's 8 times 20x to the third. The other piece is 0 over what? The bottom 8 times 8. Can you cancel anything? Can you simplify 20 over 8? By 4, that's what? 5 over 3 x to the third. And that is the correct answer.
Isn't it 2?
5 over 2, yep. There's no 3 and 8 when you divide by 4. And that is the correct answer. But for this, did I have to do it that way? If you looked at that problem closely, what does it say? Here we go. It says 5 over 8 times x to the fourth. That's what it says. So what's the derivative of that? In one step, there's that number on the front, 5 over 8. What's the derivative of x to the fourth? 4x to the third. Can you simplify that now? Which is what? 5 over 2 x to the third. So a lot of times, again, people fall in love with the quotient rule and they go, oh, but if I looked at it, boom, there's my answer. You can do it either way. You can spend a full page, or you can do it that way. You can use this method as long as you don't have x's in the bottom. Well, you could use this method even if you have x, as long as what? If it was 8x here, you can simplify that to 5 over 8x what? To the third. I can still do it. But if this was 8x minus 1, then you can't get rid of that x in the bottom. Then you're stuck using the quotient rule. So if you can simplify it and use the derivative x to the end, that's a lot quicker. Another example of keeping your eyes open. I'll think of one. Here we go. I'm going to be mean here. 2x e to the x minus x to the third divided by x. What's the derivative? Now notice I got product here, I got quotient. So I'm putting product and quotient in one problem. This will be a page and a half long if you do it that way.
Take an x out.
But if you simplify it, absolutely take an x out. What's left?
2 minus x 3 over 1.
What happened to the x's? So if I simplify this now, look how simple the problem now. What's the derivative of that? There's the 2. What's the derivative e to the x? E to the x minus, what's the derivative of x squared? The other way I can guarantee you will be a page and a half to 2 pages to do it if you did the quotient with the product rule. So a lot of the problems, sometimes you can eliminate them, or you have something like this. Y equals 9 over 5x squared. You can do the quotient rule. Or you can write that what? 9 over 5 x to what power? Negative 2. Now what's the derivative? There's the 9 over 5 in the front. What's the derivative? X to the minus 2. Negative 2x to what power? Yep. Simplify it. Negative 2 times 9. Negative 18 over 5. X to what power? Negative 3 if you don't like the negative exponent. Again, George says the book doesn't care. So I can bring it down to the bottom, make it negative 18 over 5x to the third. There are cases you can eliminate, actually, the quotient rule. There's plenty of cases you can't. You're stuck with it. You have to do it. If I gave you a problem like the one we did early, which one was that? This one, there's nowhere we could have canceled this or made it x to the power of n. So I had to do it that way. I don't have a choice.
Are we gonna get a lot of them when we have to do product and quotient rule?
Oh, I don't know. I forgot. I already made all the stuff. I can show you all my homework, quizzes, exams, everything ready. But what I put on them, I honestly don't remember. Before the semester starts, I'm motivated. I make everything. You'll see me in my office. I've been sitting in my office every morning. I sit in my office for hours, every day, I mean. And people say, what do you do? I'm there till sometimes this class, and I'm just working on next semester. So when next semester starts, all my stuff is made. I hate it, coming to a class, go, oh, we have a test. Go, I forgot to make it.